Can everybody see my slides? It doesn't matter if you can see my face. The slides is the most important thing here. As long as you can hear me and see the slides, we're good to go. So please let us know in the chat, please not the Q&A, but in the chat, if you can, if that is the case. I see a question already coming in on Pigeonhole. That's great. So for instance, JGP asked this question. If this is a question you'd like to see answered for sure, hit the upvote button here. Or if not, you can add a question of your own. So I'm not seeing anybody in the chat confirming that they can see the slides. Oh, here's Q&A again. Okay, please post a link here in Q&A too. Okay, I guess I can do that. We got 3 different chats going on right now. So there's the Q&A. So Brian can see slides. I did share it in Discord, Brian. It is there in track data. I'll post it again there in track data. Okay. All right. So let's just get on with it because we're already about 8 minutes over. So we're already taking up some of your time really for questions. So really, if you're like me, when interacting with data, for most of your career, you've used a relational database, like SQL Server, for instance, or Oracle, MySQL. So this is a question I get a lot. Why would I use NoSQL? But not only that, and this is already a question JGP has asked, why would I use this or that NoSQL database? Which one should I use and why should I do that? And I really just don't like the term NoSQL. It's just a buzzword to me, even though I work for a company that if you go to our website, it says NoSQL right there. It's not a term that I'm really a fan of. But it's really only useful for saying it's something other than relational databases, and it defines what something isn't. And it's not even really accurate anymore because, as you're going to see, maybe during the session, SQL is a language that lives in NoSQL as well. And finally, just because you're use NoSQL doesn't mean you're anti-SQL. It just means you recognize that databases are not one size fits all. So it's not much of a useful term for technical discussion. I don't think it's just a buzzword. So this is my agenda. This is all there is to it. I'm going to spend a few slides talking about the why and a little bit of NoSQL history. From that point on, is choose your own adventure. So literally, I'm going to present a whole page of links, and I'm going to go to the ones that I think are going to address your answers as best as possible. And then I'm going to do that until we run out of time. And then I'm going to give you a summary and some next steps to go on there. So let's talk about NoSQL history a little bit. Let's go way back in the caveman times before relational databases were even around. We had databases for sure, and we're talking electronic computerized databases here. The query capability was, the ad hoc query capability was very poor. You had to use low-level languages and tooling. Basically, whatever language you wrote the database in, that's what you had to query data with. You don't have much interoperability. You don't have a common language. You don't have data in similar formats able to talk to each other. And that's just the way things were. And then before SQL came along, you had this guy here, E.F. Codd. He invented the relational model of storing data, and it's designed to optimize for limited disk space because it was very expensive. If you read his paper, which I'll give you a link to here towards the end, there's a nice little quote here that was kind of prescient about some of the trade-offs that were in his relational design. Is that performance could make this advisable to not follow the relational pattern strictly. And of course, back then, it didn't really make sense to, because like I said, it's just too expensive. And he designed a language called Alpha, which was kind of a SQL-ish language that was meant to query relational data. It was never really implemented. It was just kind of a proof of concept. So then years later, SQL, the language, comes along. It's created by 2 guys, Don Chamberlain and Raymond Boyce. This is Don Chamberlain here. Raymond's no longer with us. This is a language that's designed to be English friendly. And if you've ever heard BCNF before, that's Boyce Codd. Those are the 2 people, Boyce and Codd, in there. And so they invented a language later and separate from the relational database. Now, obviously, it was designed for relational data initially, but I want to make the point here that it's really it's really not the same thing. Even though when we say SQL today, what we really mean is relational. I'm using a SQL database. That means I'm using a relational database. But I think it's important to distinguish the point that they're not really, they're two separate things. And then there's lots of criticisms and trade-offs involved in SQL and relational. So this kind of started when the web took off, and you have issues of much larger scale than computers have seen before that point. So for instance, scaling, you have two different types of scaling. You have vertical and horizontal. Vertical just means let's get a bigger, faster machine, more memory, so we can handle more requests. That's the vertical scaling. Horizontal scaling is let's add more machines and we'll cluster them together on the network so we can split the data amongst them and we can scale out. We can scale horizontally. Reason for the horizontal scaling is kind of related to this this paper here, The Free Lunch is Over by Herb Sutter. You may have seen this before, and it kind of shows that Moore's law is starting to plateau, and so you have to introduce more processors, more machines, and distribute computing, including distributed databases. Impedance mismatch is something that you've probably dealt with in the relational database world. So you store the data on the left in looks like 5 rows amongst 2 tables, just as a simple example. But in your application, you often combine that into one in-memory object. And so the way it's stored doesn't really match the way it's used in your application. So that little arrow in there, that little tiny little blue arrow, it's so simple to show that arrow, but actually you have a bunch of things like object relational mappers, entity framework, and hibernate, and so on that try to fill that gap. And they usually do a pretty good job, but not always. Sometimes you got to fight with them. And then inflexibilities, this is kind of a nice thing as well. With relational, this is a sort of a simple schema here. If I want to evolve the structure of my schema, I have to go and redefine the schema. So I have to add a billing table, I have to move data over from, say, customer into that billing table. I have to create a foreign key constraint. I have to remove those columns from customer. And I have to, add columns as I need to, change them, have to update that design up front. So that can be a lot of work. This is a simple example, but if there were, say, millions of records in here, that could mean downtime. It could mean read-only state. It could mean coming in at 2 a.m. on a Saturday, which no one wants to do that. So that's a challenge of relational databases. Now, before I proceed any further, before I get too far in and you think I start knocking relational databases, a relational database may be totally fine. If it's working for you right now, if you're not having performance problems, if you're not having scalability problems, flexibility problems, totally fine. I'm not here to say you should stop using them. Many NoSQL advocates would say, yeah, never use those again. But I think that's just that's kind of a silly way to think of things. Like relational databases still have their uses, absolutely. So that's my intro. So this is really the choose your own adventure part. I'm only seeing one question in here so far. I don't think I see anything in the chat either. I got to monitor about 4 or 5 different places now: Discord and Teams chat and Q&A in Teams and so on. So I'm not seeing anything there yet, except for the one question from JGP, just right here. Why would I use Couchbase? Well, I don't want to turn this into a Couchbase commercial. I'm happy to talk about Couchbase and all the great things it can do. But maybe we can rephrase that question to more like, why would I use a document database, which is what Couchbase is? Well, it's a document database slash key value database. So maybe we could focus in on that. So these are all the questions. I've got slides prepared for. I can also show a little demo if you want to see specifically a demo of Couchbase. I'm happy to do that. My experience is mainly with key value and document. So if you want to talk about graph and wide column, we can do that. My knowledge is somewhat shallow. Also, after my session, you've got Guy Royce coming in. He's going to talk about graph databases. I don't think I've seen that session yet. But if you have graph database questions, you might want to save those for him. He's probably going to do a way better job than I will of covering graph specifically. Okay, so I'm just going to start looking at a few of these. Oh, we've got, okay, here's a question, ACID in NoSQL. That's a good one. I'm happy to talk about that one. In fact, I just presented on this yesterday on Manning's Twitch stream about this very subject. So I have a whole hour presentation and a demo I could show you of ACID. If you want to see the demo, I could probably get that working for you real quick here. So let's talk about document first. since the question was, why would I use Couchbase? So I'm just going to give you a little intro to what a document database is. So a document database stores data in isolated pieces. Let's see, types. I'm not sure what the types question is. So maybe types of databases. I'm just publishing these questions here in Q&A. So a document database stores data in isolated pieces. Each piece has a key. So you can see that there's a little bit of overlap between a key value and a document database. It's just that the value follows a specific format. So usually it's JSON. Sometimes it's XML, but almost always JSON. It's important that each piece of data is self-contained, so it can live on any server in a cluster. You have 5 different servers that are clustered together. This can live on any one of them individually. And so this makes horizontal scaling easier because it doesn't belong to a table or a row, a column, things like that. It's just on its own. Now, hypothetically, you could have 2 documents that are meant to represent a person, but they could have different fields. So notice on the left here, we've got name, email, favorite foods. On the right, we have name, email, age, and favorite foods. And so this is completely possible because they're completely isolated. They're not in a table. They're not in a schema. That you can have this in a document database. So this is a trade-off meant to provide easier scaling. If you have flexible data needs, this is just kind of a boon for you. This is like, okay, great. This is very helpful. If you want to maintain really tight control over data, it's a trade-off that you kind of have to accept and mitigate, which we can certainly talk about. Or I have another slide we can go to on that on data modeling. So that's the basics of a document database. Okay, we got a bunch of questions coming in here. Let me see. I appreciate these questions. All right, so that's the intro to documents. Kind of the basics of why you might use Couchbase. There's a lot more about Couchbase I could talk about. Let's go to the next question here: ACID and transactions. So when I get asked about ACID, what usually people are asking about is transactions. Now, ACID is not the same thing as transactions. There's some overlap there, but they're not the same exact things. There's more to ACID than that. But let's talk about transactions. And why do we need transactions in relational? So in a relational database, we might have this shopping cart structure here. We have a shopping cart table with a date and a user or whatever, and we have a shopping cart items. This is, third normal form, so we have multiple items with foreign keys in a separate table. And then if we want to, we can join those together based on the foreign key or whatnot. So if we have our data stored like this, if we want to create a shopping cart or modify a shopping cart, we have to have a transaction because we have to be able to treat multiple operations. So like an insert in shopping cart items, or 2 or 3 inserts in shopping cart items. We have to treat that as an atomic transaction. It all succeeds or all fails. Model this the exact same way in a document database. So we could have 4 documents here representing a shopping cart. So document 1 is the shopping cart. Document 2, 3, and 4 are items in the shopping cart. So we could model it the exact same way in a NoSQL document database. And I'm calling this the naive version up there because why? Why would we want to model it like this in a document database when we can model it like this instead? So consider this way of modeling. So this is now one piece of data that contains an items array. And it's one piece of data instead of 4. And so this is the kind of place where NoSQL can really shine. So shopping carts and user profiles and things like that. Quick access to structured, semi-structured data without having to assemble all of it first. Session store, another great use for it. So we can access it quickly and frequently. We do not need a transaction to provide atomicity here. I can just make one read or write operation to one piece of data instead of 4 pieces of data. Now, that being said, the question still persists because there are still situations where you can't just combine everything into one document, right? So in my opinion is that, sometimes developers think about this, they see ACID transactions, and it's kind of a security blanket, like, oh, I can't do anything without a transaction. So maybe that kind of keeps people from making the jump. And it's also a box that managers and decision makers and Gartner and salespeople, whoever, they want to tick. They want to tick this box. So yeah, we got transactions. But once you start digging in, you're going to find, I think, that if you're modeling data in a way that you combine everything into aggregates as much as possible, you're not going to need transactions as much, but you still might need them. And so NoSQL databases have started to provide them. So you can see here, ACID, Couchbase, RavenDB, these all claim to be claim to have transactions, ACID transactions available. Now, ACID is a tricky thing, and like I said, I have a whole hour session on it. I presented yesterday. It's not there's not a standards body for it that defines what ACID is and certifies ACID compliance or anything like that, even for relational. And so there's also most definitely trade-offs here. If we're talking about distributed databases, we're talking multiple machines over the network. There's some trade-offs there in performance. A transaction is not going to be as fast as non-transaction. Okay, and so that's really it with transactions. Like I said, I have a full demo if you want to really go into it. But we got a lot more questions coming in, so I'm going to go on to the next one here and see what we can do. So types of databases, we covered documents. I could cover the other ones here really quickly. So key value. Basically, a key value is a giant dictionary. Think of it like that. All your data access is based strictly on keys. So you look up data by key, create, delete, change data by key. The key may or may not be generated automatically. Could be a GUID, could be something more semantic, whatever. And that's really your only index, is the key. The value can be whatever. So it can be JSON, sure. It can be text, XML, binary, emojis, whatever. The database doesn't care and doesn't give any special treatment based on the format. And that's a pure key value database. And again, each piece of that data can live on any machine in the cluster. So we can, if we had, in this case, 5 machines, we could have, each machine would have one key and value on it. And again, this is because of horizontal scaling. It makes it easier to distribute the data like that. So yes, the values in there doesn't actually matter for a pure key value database. Graph, like I said, this is something that Guy Royce is going to talk about later today. So I'd probably keep your graph questions for him. But graph databases really have 2 things in them. So nodes, these circles here, and edges, the arrows, the relationships between the nodes. And they're also directional. So notice that there's arrows on them. So Luke is an enemy of Stormtrooper, and Stormtrooper is an enemy of Luke. There's 2 different pieces of data there. And this is a really cool way to query data that involves relationships. So I could write a query that asks which nodes are the enemy of Luke Skywalker that also appear in The Force Awakens. Now that you could do that in relational, it's possible, but you're going to have probably 4 or 5 joins to do that, and a very hard to read and understand query. With a graph, it's a very natural thing to just express that as a sentence. Like, give me all the nodes that are enemy of Luke that are also appear in Empire Strikes Back. Very easy. Okay, so that's all I'm going to say on graph. Last one is wide column, and you can think of it kind of like a table, but it's not really a table. So each row has a key. So like user ID would be the key here, and some number of columns. And you can add columns on the fly. Data is not JSON, but it can still be semi-structured. So I have an array here in favorite foods. And data is partitioned by a partition key, which decides which node it goes to. So it's not as isolated, but it's still easy enough to distribute this data around a cluster. And there's an emphasis in wide table in databases like Cassandra on denormalization and data duplication instead of querying. So you'll often need to or want to create and maintain duplicate data in order to query it efficiently. And we can talk about that if you want to, if you're interested in learning more about that. Okay, so those are the kind of the 4 main types. There's others. There's search, there's object-oriented, there's others out there, but those are kind of the 4 main players in NoSQL. Okay, next question. Let's see. So we covered types. I want to jump over here to Pigeonhole. How large can one document be? In this case, how many sub-items can a document handle? This is a question from RVP. So that can vary from database to database. I don't have a slide for that, I don't think. So I'll click on this one. Something else that I didn't think of. So in Couchbase, a document has a limit of 20 meg. I think in Mongo it's like 12 meg. Cosmos, it's something like somewhere in the 10 to 20 meg sort of limit there. How many sub items can a document handle? I mean, if we were talking JSON, then as many as you can fit in that 10 or 20 megabytes, somewhere in there. And they generally don't get much larger than that because of the distributed nature. You're going to make backup copies of that data, replicas on other nodes. And if they get much larger than that, it's going to be a huge amount of network traffic that is just going to make it inefficient. So generally speaking, if your document is approaching that big of a size, you might want to think about modeling it in a different way. So good question. All right, let me go back. Let's see, over here to the Q&A. Let's see. Haven't a majority of disadvantages of good old RDBMS been overcome with a new generation of databases? Like Citus, I don't know what that is, Vitesse, I don't know what that one is either, and Yugabyte, etc. Well, I mean, so I think you're probably talking about the NoSQL movement, maybe you're referring to. So I'm not familiar with those you mentioned, but certainly like CockroachDB and Google Spanner are out there that are relational databases. And I wouldn't say that the disadvantages have been completely overcome. And there's lots of trade-offs still involved in that. I don't have a slide on NoSQL in here, but I do talk about that also in my transaction session I did yesterday. I mentioned Cockroach DB and some of the things you have to think about with that. So, I mean, if that can be, if you're really set on relational, that could work for you potentially. But there's other things you have to think about because it's still distributed. So there's still a network in there. So if you want to go with cloud-based CockroachDB, they may manage some of that stuff for you. If you want to do it on your own data center, then you're going to have to worry about things like syncing up your clocks and making sure your servers meet the minimum requirements, things like that. Setting up stuff like Zookeeper or Paxos algorithms to kind of manage that stuff for you, or Paxos implementations. So it is not like, oh, NoSQL is no longer useful because of Cockroach and Yugabyte. No, it's not really the case. It's just a different set of trade-offs. Okay, let's see. Next question. I started using a new app. Using Mongo. I've used Relational for a long time. How can I transfer to Mongo easily? What are some gotchas? I don't work for Mongo. You're probably gonna have to talk to them about how you want to transfer to it. I will say transferring to Couchbase, there's lots of import tools, and I think Mongo has similar ones to import from CSV, and there's connectors. So let me see. No, not that one. I want to go to migration synchronization. Maybe touch on that, or maybe on modeling. Those are kind of some overlap there. Let's start with migration or synchronization. So again, I wanted to ask the why up front. Why do you want to move data from one database into a NoSQL database? And this is a serious why. This is not a sarcastic Ryan Reynolds why. Why do you want to do that? What are you hoping to gain from doing that? So if it's scalability, if it's high availability, performance, offloading your mainframe, something like that, yes, let's do it. Let's make that switch. If it's you don't want to pay Oracle anymore, okay, we can do that. That's not as compelling a reason, I think, but okay, we can do that. If it's because you want flexibility, I would say be careful there. What do you mean by flexibility? What do you hope to gain in that flexibility column? If the answer is I just want to put NoSQL on my resume, nope, not really a good reason to migrate a working code base from one database to another. So I would say before you get into the how, get into the why. What's your architecture? What's your use case? What's the effort it's going to take? And what are the benefits you're hoping to get? So in my view, relational databases are kind of like a Swiss Army knife. You can make them do just about anything, especially in an emergency. But a professional chef doesn't use a Swiss Army knife. She's going to use the best tool that she can for the job. She'll have a whole selection of knives for different tasks. But if you're having those scaling, performance, flexibility problems, then maybe you don't need to convert everything over. Maybe you can just take one slice of your application, of your architecture. So if the user profile is the part that is scaling is a problem, or you need flexibility there, then maybe just put that one part into a document database and leave the rest in relational for now. And that's totally fine. And if you, especially if you have a microservices architecture or a distributed or SOA type architecture, this is a little easier to do because you don't have to convert the whole thing over to use the same database. And there are some tools to help you with this. So this is probably what you're asking, Jim. There are a lot of tools that can help you move this over. They all have different capabilities, different features, different prices even. And most NoSQL databases provide some basic tooling to import data. But understanding synchronization, understanding modeling is important for here as well, because as I showed you early on with the shopping cart example, it's not exactly a straightforward, just move my data from here to here. It's not as simple as export, import. Okay, so maybe we can talk about modeling a little bit. I think that might be a good next place to go. So let's talk about document modeling. And again, I'm going to start with relational because I think most people understand relational. The rule of thumb is pretty much third normal form always, right? Design your tables like this. So you have foreign keys to join them. So a shopping cart has many shopping cart items. A Twitter user has many tweets. And that's pretty much always how you do it. I'm not going to cover all of relational modeling today, but that's basically what you need to do. And with document modeling, it's a little different. You want to denormalize and aggregate as much as it makes sense to. So in this case, the size of a shopping cart is relatively bounded, right? It's not going to even get close to that 10 megabyte, 20 megabyte limit that we just mentioned earlier. It's going to be relatively bounded. So a shopping cart with 100 items would be a crazy outlier and would probably still fit inside the 20 megabytes. And rarely does a single item in a shopping cart need to be read and written on its own. There's some ways we can do that, but usually it's the whole thing where you're adding things to the items, stuff like that. If you're familiar with domain-driven design, think of the documents as kind of like being aggregate routes. So the main concept here is shopping cart. That's the aggregate route. And the shopping cart items are just an auxiliary table. In fact, Martin Fowler even said in his NoSQL book and his NoSQL presentations that aggregate-oriented database is a better name for document databases. I absolutely agree with him, but it hasn't really caught on, unfortunately. Model it like this. We could keep it normalized if we wanted to, if we needed to. So in this case, it would be nice if I could put all my tweets into a single document. But if you notice on my Twitter account, they're not going to fit in a 10, 20 megabyte document. So it really doesn't make sense to. Then the number of tweets is relatively unbounded here. So a user with 100 plus tweets, that's common. More than 20 megabytes of tweets, absolutely possible. And often, tweets are going to be read and written in isolation, right? I'm going to just read the latest tweets or post an individual tweet. So it doesn't really make sense for me to grab a whole collection just to add one tweet to it, especially because it's going to be unbounded in size. So those are a couple of considerations I would think of when you say, I'm going to move my app to, oh, well, your question was a new app using Mongo. Okay, so it might be okay. Maybe I was a little too much about the why at first then for your question, but I think in general, if you're thinking about moving from relational to document, you got to think about those things. But in Mongo and document databases, you got to think about how am I going to model this data? Is it going to be this approach or this approach? And probably it's going to be a combination of the two. You're going to use one for one type of data and one for another type of data. So those are some things you have to think about when you have a relational background and you're going into document databases. Okay. What else we got here? Question, are in databases, are fields and columns the same thing? So like in a document database, so I call these fields, I mean, technically in JSON, I think they're called key value pairs, but that's a little confusing to talk about key value pairs inside of a key value document. So I call them fields. I wouldn't necessarily say it's the same thing as columns because right here you have an array. You really don't have arrays in relational databases. I mean, you can put, XML and things like that into a column, but you don't really have an array construct, and this is a JSON thing. So, but roughly speaking, I'd say it's mostly analogous. Yes, I think it's a fair thing to say. Okay, what else? Over here on A pigeonhole, just as a reminder, the bottom left there is where you can go to ask questions, see what others have asked, and vote their questions up if you want to see more about them. Question from Adnan. Is it encouraged to use an ORM like Entity Framework to connect with a NoSQL database? I mean, really, this is going to be up to you. Let's see. So, I mean, what is it that Entity Framework? So, with the modeling I mentioned here, with Entity Framework, it's going to do a lot of this stuff in the background to perform those joins and mapping, things like that, to your C# objects. I think I had a better slide on it, actually. Where was that? Was it earlier? Yeah, like right here, right? So Entity Framework is this arrow in the middle. And so Entity Framework is going to, join, do the number of queries, maybe multiple queries, maybe a join or whatever, and pull in that data, and it's going to map it to a C# object or C# objects like this, or Java objects or whatever. Now, with a relational or with a document database, we're back to here again. I have a JSON object here. It's just one piece of data. I could serialize this directly or deserialize this directly to a C# object with Newtonsoft or system.text.json. Is that what it is? I don't have to go through a mapper to put this into a C# object. It's actually, there's no impedance mismatch, right? So that is one of the things that Entity Framework and Hibernate ORM tools like that help to solve. So what else is there that you'd want to get from Entity Framework? So you might want to get a link provider, for instance. If you want to write link queries instead of having to write literal SQL queries or Mongo, whatever their query language is called, Cassandra's query language, things like that. So in that case, you might want to use Entity Framework. Is it encouraged to? I mean, that's, again, I think it's up to you. ORMs are somewhat controversial from time to time. Like, some people swear on them, some people swear against them. So it's maybe down to your preference. But if there's a question hidden there, are there Entity Framework providers for NoSQL databases? Yes, there absolutely are. So I know Mongo has one. I know CosmosDB has one. I can't think of any other document database off the top of my head. I don't know if Dynamo has one. They probably not. They might. I don't know. Couchbase does not have one. However, Couchbase has a link provider. So if it's the link part that you want, you can just use the link provider. Let's see. I think there's another question in here from RVP. Okay, is scalability and flexibility the only reason for choosing a document database over relational database? Scalability and flexibility. Well, I think I mentioned performance as well, and maybe there's a performance one in here. Yep, we can talk about performance. So performance is another reason that people, NoSQL database companies and projects say, oh, you should use our database because we're faster. And they usually publish benchmarks. So I want to talk about benchmarks here first. Because in my mind, benchmarks are something that you really do for yourself. It's not really something that you want to depend on a vendor for. So you try something, you benchmark it, you make a change and see how that compares to the benchmark. And if you're building database software like Couchbase is doing, you can automate this as much as you can. So this is a screenshot. This is a completely public website, by the way. It's called ShowFast there at the bottom right of all Couchbase's benchmarks for all of our internal builds. And so I don't know how old the screenshot is, but you can see just over here, for instance, our 6.5.1 build 6262 did this many operations. And that's about consistent with the last build 6107. But then, 7.0 build is about 1 million faster. So something changed there in our engine or optimizations or whatever. And 7.0 is not released yet. But as you can see, as we add more features and flesh it out, then the number starts to change. We go from 3.6 down to 3.5. And maybe that's because this early version was a little bit unstable, taking some shortcuts that were leading to errors. Who knows? So we've slowed it down a little bit, but it's more correct. So these are benchmarks in my mind. This is what benchmarks are, and these are complex. This is just one possible view of it. And you can see, Each of these has a number of nodes and a read-write ratio, and how big are the JSON items, and how big is the batch size. And this is just for key value. There's also querying and eventing and analytics. What are the benchmarks for those? So it's a very complex situation. But when people ask me, and they come up to me a lot, and they say, "Hey, do you have some benchmarks?" And I think maybe this is what they're looking for, or this is what marketing thinks they're looking for, because we publish stuff like this all the time that says, the higher the better, right? So the green ones, those are losers, and the yellow ones, those are chumps, and the orange one, well, that's us, of course. We have the tallest of them all. We have the best benchmarks, and these benchmarks are often commissioned and published by the vendor or the project themselves. So yeah, of course, they're not going to publish a benchmark that makes themselves look bad. So I think what people are often asking is, are you faster than a given competitor? And I already showed you how complex the benchmarks are. So the answer, of course, is it depends, and it's complicated. So I'm not saying ignore those benchmarks, but look at the source and look at the details. There is a benchmark framework called YCSB. I think Yahoo created it. It's a series of benchmark definitions for different use cases, and there's hundreds of them, and so we may only publish the one that makes us look really good, and there may be some that we do really badly in, and there may be some where we're just about even. So there's lots of different use cases. You can't just say in a blanket statement, we're faster than X, period. It just doesn't make sense. And so I think it's more important to look at the architecture. Look at the high-level architecture of the database. How does it use memory? How does it use disk? Does it have a built-in cache? Does it use memory for cache or buffering? Is it memory only? Is it disk only? If you're deploying to a cloud, which data center are you deploying to, or data centers? And what's the latency there from where most of your users are in the world? If my data center is in the East Coast and most of my users are on the West Coast, latency is going to be higher. How much concurrency is going on? Is there going to be a lot of people reading and writing the same data at the same time, or a lot of people using the system at the same time? And what about queries and indexing? That can be table scans, primary scans can happen in NoSQL too. So you got to have good queries or good indexes on those for the performance. So performance is another reason, but you already saw earlier how I condensed a relational database that was like 4 operations into 1 operation with NoSQL. So that can be a reason why you'd want to use NoSQL as well. But in my mind, it's scalability, performance, flexibility. There's another one, I think. What was the other one? I usually have like big 4. Oh, high availability. High availability is another really good reason. So here's it right here, scaling high availability. We can talk about this a little bit if you want to. I've got some cool animations here, so I kind of want to show this one off. So there's a couple different ways to deal with scaling. And so what I'm showing you here is primary, secondary. Now, this used to be called, and sometimes you still might see it written this way, so this is why I mentioned, the only reason I'm mentioning it, so this is called master slave. Now that naming is sort of on its way out, but you still might see that in documentation and books, so that's the only reason I bring it up. So the way this works is you have a primary database server and you have several secondary servers. So I'm going to write some data to my primary server. I'm always going to go through my primary. That's my single point of interaction with the data. The primary database is going to say, okay, I'm going to make some backup copies just in case I get hit by a bus. And I'm going to send those off to my secondaries. I'm going to back those up to my secondary servers, okay? And that's how it works with the primary secondary model. All right, now for read, again, I'm going to go directly to the primary all the time. I'm going to read data from the primary. That's it. It's possible maybe to read from the secondaries, but it's definitely not recommended, especially in some systems. So why do we even have the secondaries there? Why are those even there? And the answer is a failover for availability. Because what if this server crashes, goes down, gets unplugged, disk catches on fire, gets corrupt, or whatever? What happens if that goes down? Well, then we look at the secondaries and we elect a leader there. And this may be an involved process. It may be automatic. Who knows? And we say, hey, guess what? You're in. Wally Pip is injured today. We're bringing in you, Lou Gehrig. So you become our new primary. And then, then we deal with that primary server that went down. Maybe if we get it to come back or whatever, it can be the new secondary. All right, so that's one model of scaling. This is for high availability, because if I just have a single database server, a single machine, if it goes down, my whole system goes down. And so in this case, we have backups that provide us high availability. Another model for this is called the shared nothing, also called masterless or peer-to-peer, various different names for it. But now I have a bunch of nodes, and none of them are secondaries, none of them are primaries. They're all equal. They're all on the same footing. They can all do reads and writes. So I want to do a write here. So what I have to do is I have to come up with a map that says for any given piece of data, it belongs to a specific server. Maybe this is a CRC32 algorithm or some sort of hash algorithm that just says, okay, this is your document, we're going to hash it, and the hash tells us you get server 3 for now. So then I have that map, and that map has to be given to the client, so the client has a copy of that map, so it knows where to send the data. So the client itself says, okay, the map says I'm going to send the data to you, server number 2, and that's where data 1 lives. And then that server is going to say, okay, I'm going to make some backups, and I'm going to send them off to my friends. So they're going to live on these other servers as a backup, as replicas. So once it arrives to the node, those become replicas there. Now this may look similar to the other model, but I can send another piece of data to another server here. So again, this is every node can do reads and writes. So data 2 goes here, and then I have data 1 or data 2 backups, and they go off to, maybe it goes here, and maybe it goes here. This is all based on a hashing algorithm where they go. This doesn't really matter to a developer. They go somewhere. So you have all these nodes that have a combination of actives and replica documents. Okay, now for a read, again, we still have that map, so I know where to look. I want a given piece of data, so the map tells me I'll pull it from number 4 there, and there we go. That's it. So I have to know which node to look for. I don't have to go through a primary or anything like that. As long as I have the map, I'm set to go. So what happens if one of these nodes fails? It gets cut off from the network, melts down, whatever. So this one crashes, and it has the primary copy of data on it, of data 1. So once the other nodes see this, they're like, hey, our friend node number 2, he's down. We gotta help him. Once they recognize this, they're going to go into failover mode, and they're going to say, well, let's find the replicas for that, and we're going to promote to a primary active here on node 4. And the other ones may, do the same thing. Imagine 100 pieces of data. It's going to be split between 4 nodes. So each of them does 25, promotes 25 replicas. So they pick up the architecture there. I can see that I'm kind of running low on time here. Actually, I'm running out of time here. I got about 10 minutes till the next session. I can about 5 minutes left in mine. So let me just look for maybe one more question here. I'm looking on Pigeonhole. How would databases like Postgres that can store a combination of relational data and JSON data in one of its columns? Would you recommend this over a DocumentDB? Let's see. Yep, here's this one right here, JSON in Postgres. Basically, the question is Postgres the new NoSQL? So there's a SQL standard 2016 introduced a set of functions that can be used to manipulate JSON data. I don't think anyone's really following the standard to the letter. That's not a big surprise. That's always been the case. But Postgres seems to be the best implementation so far. SQL Server and MySQL, some of the newer versions, have some functionality as well. So if I can manipulate JSON in a relational database, then why would I use a NoSQL database? That's the question. So we have this, we have some functions to deal with that. So yep, that's the answer. It's the new NoSQL. Let's just all go home. You asked the right question. Let's shut her down. No. Unfortunately, the answer is this one. It depends and it's complicated. This is the real answer to every question in computers, by the way. I should have just put this up as my one slide and called it a day. So I have a colleague here, a friend named Dennis Rosa, and he is a speaker and advocate as well. And he wrote a blog post here comparing Postgres JSON-B, they call it, to NoSQL. Because Couchbase actually has a SQL implementation. Yes, it's a NoSQL database with SQL. So he compared and contrasted the two approaches. So one of them is SQL 2016, one of them is SQL++. And so some of the things he talks about in that blog post, I recommend you check it out. I'm not going to read the whole thing to you, but is querying limits there, indexing issues, tooling issues are maybe not there yet, documentation is maybe not there yet. And one before thing, you might say, hey, wait a minute, that's a Couchbase link, couchbase.com. So it's obviously going to trash Postgres. Absolutely not. It's a very fair, and it's actually a well-received piece, even by the Postgres community, who has touted it as a very fair breakdown of compare and contrast. So I recommend that blog post to read on that topic. And furthermore, this guy here, Don Chamberlain, yes, the same one I mentioned earlier in the presentation, he wrote a white paper that compares the two as well, SQL 2016 versus SQL++. And so as one of the inventors of SQL, I think his opinions are going to be very useful. So bit.ly/comparing SQL, that's a capital S in that link. You can go read that white paper and kind of compare and contrast straight from the inventor of SQL. By the way, he also is on the advisory board at Couchbase. So yeah, he may be a little biased too, but he's also an inventor of Couchbase. So. Sorry, the inventor of SQL, not Couchbase. But finally, if you really want to explore this more and you really want to take this approach, there's several libraries out there. Probably the most mature one is called Martin. It is a .NET library that works with Postgres to provide a document database interface. There's some other ones out there, but it's basically all Postgres behind the scenes. So scaling still may be an issue, and performance and indexing, those things are all still going to be an issue. Okay. I think that's all I really have time for, sadly. I absolutely can take more questions in the Discord after this is over. I want to get to a summary real quick. Scaling, that was kind of the original reason, but it's evolved and matured a lot since then. NoSQL is just a buzzword. Dig into those specific types, and it just means that databases are not one size fits all. Always think about the why. What database problems do you have? Scaling, flexibility, performance, high availability, what would help you solve them? Do a proof of concept, try them out. You can find me on Twitch, on Twitter. This is my Couchbase email address. A conference coming up here. You can learn all about Couchbase, dive into it specifically. Free conference, swag, prizes. This says 60, but I think it's actually 100 sessions now of developer content. Sign up for that. Please use this link. It's totally free to sign up, but if you use my link here, my boss said he'll buy me a pizza for each person who registers. Not really. I wish he would, but I would appreciate if you sign up using this link here. So that's all I have for right now. I do want to be courteous to the next person speaking, which is the great Guy Royce. So you had graph database questions, you can ask him during his session. But great to see you here, Guy. I'll be in Discord answering questions. If you have any more, there he is. The great Guy Royce. All right. Well, thank you very much, everybody. I appreciate you all hanging out here on a Saturday in Microsoft Teams to do some great learning, and I hope you all have a good weekend.
Thank you very much. We really appreciate that presentation.